Hi there, Miss Lam here. So first of all, I want to share 3 common questions asked by students during the practical in IAs, such as how to make the solutions. Okay, 3 questions. So first question that students like to ask is, what concentration should I use? Okay, so they always come to me and then ask me, what concentration should I be using? My answer to that is absolutely no idea. Okay, I don't know, therefore my answer will be alien. Okay, now, but what I can suggest you to do is, okay, you can do some pre-test, okay, pilot study. Okay, so for example, such as using a log, kind of like a log scale to find out the suitable range. So for example, if you have absolutely no idea as to what concentration you should be using, I would suggest you to use, first of all, try out a few tests on 0%, 0.1%, 1%, 5%, 10%. Now, please note this is the log scale only. This is not the actual concentration that you should be using, because IB, they do prefer a linear scale. Okay, and then so first of all, you test this out, okay, and check which 2 of these, okay, works the best. Okay, so what we mean by work the best is, okay, so let's say if I want to look at the antimicrobial effect of something, okay, and then I test this and it turns out, okay, let's say 10% is too high, okay, then it kills off all the bacteria, so there's no colony to count, then this won't be a good concentration to work on. Okay, so another one is, for example, if I test for 0.1%, okay, it turns out there's a lot of bacteria colony. It's impossible to count the colonies. Then again, 0.1% will not be a good concentration. Okay, so you need to base on the results and find out which are the good range. Okay, and then because of the IB requirements, so first of all, we prefer students to use a linear scale. Okay, that's first thing. And second thing is, in order to establish a trend, okay, to cause if there's a correlation between X and Y, okay, then you need a 5 increments, okay, plus a negative control. So in the case of just now, we say that, okay, 0.1% is too many bacterial colonies, so it's no good. 10%, it kills off all the bacteria, so it's no good. So you're working between 1% and 5%. Then your linear concentration range would be 0, 1, 2, 3, 4, and 5. Okay, so that's how you find out a concentration range that you need, okay, for your experiment. And then the second question people like to ask is how to make those solutions. Okay, they always come to me, Miss Sam, help, I need some help on this. So I hope you have watched this video, okay, because by that time I will probably answer you this. Okay, so 雞蛋咧6隻，糖咧2茶匙，仲加啲橙皮添。Okay, now because actually it's very simple. Okay, so you need to look at your sauce. Okay, whether it's solid or liquid, and then you have different approach. So if let's say if it's solid, okay, so some solid powder, all you need to do is just, let's say if I want to make 1%, then it's 1 gram plus 100 cm cube of distilled water. Okay, so that's very easy. And if it's insoluble, such as if I want to make 1% black tea, okay, from black tea leaf, okay, then what you need to do is 1 gram of black tea leaf plus 100 cm cube of this distilled water, and then you filter out the leaf. Okay, the same can be applied for, let's say, pig's liver and things like that. Okay, the next one is if your sauce is a liquid. So for example, let's say if you want to make 1% Yakult solutions, okay, what you can do is 1 cm cube of Yakult solution plus 99 cm cube of distilled water. Okay, so just one thing, if you're making the liquid, then you need to deduct the volume. Okay, so you notice that this one is 99 cm cube, not 100 cm cube. Okay, now but 99 cm cube is actually quite hard to take. So what we can do in order to prevent any inaccuracy, okay, or error in the experiment, that helps with the next one. Okay, next part we will discuss a little bit more. Okay, for question 3. So next one, okay, question 3 is what happens if I need a really dilute solutions, okay, such as really low concentration, like 0.01%, 0.001%. So what can I do? Now the lab or our lab have electronic balance as sensitive as reading 3 decimal place. However, we will not encourage students to measure 0.01 gram, okay, plus 100 ml of water. The reason is because if it's so low concentration or so low mass, okay, there will be transfer loss. Okay, so when you scoop those out, okay, it's possible that you miss out some residue left on the spatula. So what we can do, Okay, so I want you to remember this. Okay, so if you want to make very, very dilute solutions, okay, think of a Homer Simpson falling off down the stairs. Okay, serial dilution is your answer. Okay, it's not complicated, very easy. So let me walk you through it. So for example, first of all, you need to prepare some clean test tubes. Okay, fill them up with a 9 cm cube of distilled water first. Okay, then you get your stock solutions, and then for example, you get 1 cm cube of the stock solutions. Okay, and then transfer it to one of the test tubes. Okay, then you will make 10%. Okay, after you make the 10%, then you extract 1 cm cube of the 10% and then add on to the second test tube, then you get 1% and so on. Okay, so if you repeat several times, then you can get up to 0.01%, and eventually every time you scale down by 10%. Okay, so that's how we can do a serial dilution. Another good thing about the serial dilution is you don't have to worry about, so first thing, you don't have to worry about if there's any transfer loss. Okay, if you use the old method, such as you measure 0.01 gram of salt plus 100 mils of distilled water, okay, that not only there's a transfer loss, okay, plus there's a lot of waste. Okay, so sometimes if you buy something that's very expensive, okay, you don't have, like, say 10 grams or something like that, okay, then what you can do is you can use the serial dilution as well. Okay, so for example, I have a case where a student is running out of honey, okay, specific honey that she bought, then she can use a serial dilution eventually to make up to 0.01 percent of honey solution, things like that. So that's the 3 questions that is commonly asked by students, okay, during practicals. I hope this helps. Okay, so thank you and bye.